I'm Julian from the UK. You've probably got that bit, one of the 12 countries. Glad to be back in Budapest. It's a great city. This is the official title, but I got bored with the official title. So I'm going to challenge you to think about software testing, and does it really need to be the way that we think it is? So I want to start with setting you a provocative question. When we're working and doing something, let's pretend we're testing some software, we've got a bunch of questions in our head. Do we want to achieve perfection? Zero bugs. That car driving down at 220 kilometers down the freeway this morning, we probably want zero defects from that software. But quite often, we want to get to good enough to get the boss off our back, the development to be happy, whatever it is for us. Or do we simply want to improve on what we've got today? And the next challenge is, do we limit ourselves in testing to what we know, to what we believe to be true? And I believe that most of us do, so I'm going to challenge you to think beyond what you know. Like Isabel mentioned this morning with Donald Rumsfeld, let's think about what we know we don't know and realize that hidden behind that is this vast swathe of stuff we don't even know we don't know about. So all these lead to very, very different outcomes in software testing. And now I have to see if this works any better for me than it did for Isabel, which it seems to. Good. I've worked at Google, eBay, Salesforce, a bunch of these fancy companies that most of you have heard of that are recognized as being quite good at writing software. Even in the best development teams, the ones who write software used by 1 billion people, we're limited by our worldview, our understanding of what holds to be true. I'm from England. Guess what I recognize as my favorite language? English. I test in English. I think in English. So what happens if my software is being used by people in 100 countries? Can I even contemplate what's involved in Hungarian? The words are a bit longer. They don't quite fit the little dialog box I put together. Arabic. It starts over there and it goes here. What the hell? And then they put the numbers in this way. Does that make any sense to me? I've got to be able to think about things beyond my understanding if I want to do good software. So analytics helps us back up our decisions using data rather than just our own little worldview. The second thing, and I think for all of us, we're driven down to this, is cost. Cost of operations of business. Companies will spend millions and tens of millions to reduce the cost of operations. Normally, that leads to automation. I'll give you some examples where software testing is now fully automated. And it will drive down the cost, and this is the way the industry is going, so we need to think about this. The third thing is, how many of you test software? Most of you? All right, good. You're in the right place. So where are you sitting for your testing? We're sitting at a desk. We're on a computer. We're on a little mobile phone. Some of us go outside, and we go out into the real light. Oh, sunshine. Very good. We do a little bit of testing outside. But how many of us go to India? How many of us sit on a bus and do our testing? How many of us are testing while we're running like Isabel was yesterday from one airport gate to another? Which bloody gate am I in? B7. Oh, shit. You know, running the other way again. That's how most of our software gets used. So analytics helps us to understand how our software is being used, so perhaps we can improve the quality of our testing. The first challenge for us then is machines versus testers. I was in America a couple of weeks ago for a conference called Star West. I happened to meet some old friends from the Google days. They've created a company called AppDiff. Guess what AppDiff does? It looks at the differences between applications, mobile applications. What they did is they downloaded the top 15,000 applications from Google Play. Most of you got Android phones? Some of you? So you're familiar, there's about 1 million apps out there. Downloaded the top 15,000 and automatically drove the software. They interacted with it, they tried to log in, no intelligence, just try everything, see what happens. And they recorded the timings, they recorded the screen changes, they recorded on a bunch of different devices, all automatically. They keep track of the records. So this screen transition took 16 milliseconds. The new release comes out of the software, they automatically do the same thing again. 73 milliseconds. 16? 73? Is there a difference between 16 milliseconds and 73? Yeah? Does it matter? Maybe. So this is an automatic heuristic oracle. By that, it means they don't know what the application is. They don't know if it's Facebook or Gmail. What they do know is there's a difference between the two times, and perhaps that's important. So they send that information back to the development team and say, hey, just so you know, we've noticed that your dialog box has got more stuff in it, and it takes a little bit longer to load. Do we care? This is automatic and essentially free. So those of you testing mobile apps, this is automatic and free. And it takes about 10 minutes. How long does it take you to install the software again? Never mind. So this is the way the world is going. They look essentially at three things: visual changes, the change from this app to the next release of the app. They look at timings, and they compare with your peers. So whatever your app is, you're an online e-commerce site, they compare you against other online e-commerce sites. Not that hard. When we upload an app to the App Store, we say, it's an e-commerce app, it's an education app. So they have some sort of clue, and then they use machine learning to improve this algorithm. So where they've started today, in 6 months' time, a year's time, 2 years' time, this is where the industry is moving. Have any of you heard of monkey testing? All right, so monkey testing comes from the concept of a dumb monkey doing the testing. Typically, it's a piece of software. The original term, I believe, comes from Microsoft about 15 years ago. And there's now the concept of smart monkeys and probably super smart monkeys. And anyone in academia done a master's degree, PhD? Not many of you. OK. One of the great things that academia tries to do is say, when we're writing test automation, our clever, super wonderful thingy has got to be better than dumb monkey. Because we, the clever PhD, whatever we are, can't beat the dumb monkey. We kind of missed the plot, haven't we? Surprisingly, monkey testing, and Android monkey is the one that most people use as their reference point, finds maybe 40% of the crash bugs, more than many of the better ideas from academia. So this is from Google Play, and what I'll do is I'll try and give you some idea. This is a pre-launch report. This is version 30 of a piece of software I'm responsible for, 31, 32, and 33. Anyone spot something weird about 32? There's a little bit of red there, isn't there? There's actually 7 devices with issues, and lo and behold, they agree with me. Amazing. And here's some of the errors. There's a Motorola G first generation, it's Android 4.4, and they happen to be testing in Hindi. I don't know, Google does it for free. Ooh, what's this say? Android view inflate exception binary XML file, blah, 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 blah. OK, with me so far? I didn't do anything, they just uploaded the software. I click on this one, and here's what I get. It said it took 300 seconds. It tells me Android 4.4, screen density, a bunch of other boring stuff. Here's a screenshot saying, unfortunately, QX, the application, has stopped. We're familiar with that? Application crashes on our phone. This is a 15-second video for free that just shows me what happened, what it did. Pretty good, eh? And for every single one of the 11 devices they test on, they do that for me. This one is a working one. It's a Nexus 5. And do we see we've got something happening on the screen that looks sort of OK? This one's a crash. This is a failing one, the old Motorola. So I've just given you a comparison of the two. Well, let's look at the list. These are the 11 devices. This is what's presented to me as a developer automatically about a day or so after I've uploaded the app. It's fairly slow at the moment. Anyone spot a common pattern? Is there something in common between the failure and the passes? Anyone want to shout it out? Android version. Look at that. 4.4, 5 point something. So it seems like we've got some sort of problem with 4.4. Does that help us isolate the bug? Possibly. We look down here, and it's a bit weird, isn't it? We've got 3 of them with this inflate thingy, inflate exception. We've got 4 that don't have it. Actually, all 7 of them have the same exception. But there's a bug in the reporting by Google, so they don't tell us for the 4, even though it really is the same bug. But it takes a couple of minutes to click through and go, yeah, OK, look at the logs. And by the way, we can get what's called a log cat, the full logs from the system logs from the phones to see what happened and compare them. So what do I do now? Well, my bag's down here, so I've got a lot of phones with me. I pull out a little Samsung S3 running Android 4.4. I install the app, and I press the settings button. Bang. Now, you might look at me and say, what the hell's he doing? They've released an app to the App Store, and they didn't press the settings button on Android 4.4. What a lazy, shallow tester, especially standing in front of you here. However, you'll find that apps quite often aren't fully tested, and we don't think through the permutations of this device and that device, and someone, I guess, assumed that settings was kind of okay. Well, it turns out it isn't. There's a bug in the Android library that we used on 4.3 and 4.4 of Android. And if you go to a site called Stack Overflow, research this error, you'll find enough programs that said, by the way, you're using the wrong library. You need to use this view instead of that view. Problem goes away. The developer fixed this within about 45 minutes. We'd uploaded it to the App Store that night. We'd had a couple of users complain already saying, 1 star, your app crashes, that correlated the problem we'd seen. So by the next day, we'd already fixed the problem. So not bad in terms of automated feedback. Let's see if this is going to work for me. Data mining. Now, most of you heard of Microsoft. Do you know they've got a big research group? They're doing some of the best work I've ever seen, particularly in software development. This is a nice paper called How to Smash the Next Billion Mobile App Bugs. Not million, billion app bugs. So for those of you who've got Windows phones, anyone? Yay! Good. There had to be some users left. So for those of you who use Windows phones, you're aware you've got a mobile Windows store. Probably got some new name with Windows 10, and you can download apps. And on your mobile device, if there's a crash, the same as Android, the same as iOS, same as Windows Phone, if there's a crash, it sends a little update to the servers, to the App Store, and says, oops, this application, Skype or whatever it is, just crashed. With me so far? So what they did is they looked at all the crashes for a year. All the crashes for a year is around 25 million crashes. It's quite a lot of crashes, isn't it? And they used machine learning, and they reduced that down, and essentially worked out that roughly it was caused by about 10 different things, these crashes. Here's where the smart bit comes. They've got a bunch of servers. They've got Azure. They've got clouds of servers, thousands of damn things. So what they did is they spun up lots of emulators. They put 3,000 of the apps from the App Store. That's quite a lot for Microsoft. And they automatically tested them. They instrumented every single one of these 3,000 apps automatically. They tested for these common problems. And what they did is they had this thing called fault-inducing modules. The first one is a web error. How many of you are testing web stuff? What's 200 mean to you? 200, what's it mean to you? OK, 200 is OK. So most of the time, a web server, when you make a request to it, will respond back 200, which means OK. And then whatever the thing is, it's supposed to respond back. Maybe it's a protocol message, maybe it's a web page, maybe it's an image. Who cares? The 200 is a magic bit. So what's a 404? Most of us know what that means. It means a page not found. 401? Authorization, authentication. 500? Server error, etc. So you get the idea, don't you? So how many of you would think that a programmer who's writing something that goes to a web server and asks something would write a little bit of logic saying, if 200, do what you're supposed to do. If 404, do something else. If 500, do something else. Who cares? You know, as long as it writes some code that handles a 200 versus a non-200, we're probably in good shape. But sadly, so many of these apps crashed because no one had bothered to write that code. All they did was assume the 200 back, and guess what? From time to time, the apps got something different back because the servers were in some weird state. They were overloaded. There was a network error. You had a proxy error from the hotel. Who knows? Who cares? But the app crashed. So they boiled this down then to web errors, in other words, the error codes, poor network conditions. I'm in here, Wi-Fi is quite good. I walk outside. I'm roaming on 3G. It's not so good. I go to the hotel room. In the elevator, it doesn't work at all. So how the hell does the application cope with that if no one's written the code for it? Again, all this was found automatically. They actually sent back to the developers the automated test that said, just so you know, your app crashed with these common problems. Here's the automated test. Do you want to run them and see if you can fix your code? For free. So where were the testers in this? This is where our industry is going. Does anyone know who Carmen and George are? It's an academic paper, one of the bazillion ones I've read. I was quite excited by it because it was talking about exploratory testing and exploratory testers. And Isabel, I think you said you were involved in this study? So Isabel was actually one of the people who was volunteered to be one of the 40 people they assessed. And essentially, Carmen's are the people who haven't got a qualification in software testing. There were 20 of them. Georgia's have. With me so far? So how many of you hold a certification in software testing? All right, so about half of you. So we're about equally balanced now, aren't we? We've got a bunch of Carmens, those of you who haven't, and a bunch of Georgias. So what they did is they got them to test some software. And they got people to do something called thinking aloud. And thinking aloud says, when you're doing something, so I'm pressing my watch and checking the time, is thinking aloud. I'm saying what I'm doing. I'd explain why I'm doing it and what I'm thinking about. I think there may be a bug when I press this because the screen update doesn't work properly. So people are doing that as part of their testing. They're filing bugs on the software, and we then go and analyze all the bugs. So they found there were differences between the people who haven't taken a testing certification and the ones who have. The ones who hadn't didn't find quite as many bugs. They found certain types of bugs that the ones who did have the qualification didn't find as many of, and vice versa. So we found there were differences in the bugs they found. Both sets of testers, who were being recorded, by the way, with eye tracking software, were doing both, should we call it structured testing and unstructured testing? I'm deliberately not talking about exploratory testing here. In other words, they were applying a testing method such as Isabel mentioned this morning, remembering after about 2 hours to do boundary value analysis. Duh. So, and then sometimes they're just wandering through the software and finding bugs. And what I found so important from this study is that we need to be able to use both techniques. Sometimes we need to use structured techniques and think, of course I've got to use boundary value or equivalence partitioning. And no matter how complex a system is, sometimes that holds true. And other times we need to find ways to explore and go beyond the structured techniques in our testing. So be aware that we can actually measure the efficacy of exploratory testing and the work that we're doing. Next thing. This is to do with a TDD design course. I think it was a 3-day course. And this is a friend of mine based in India called Naresh Jain who did this work. And essentially, he was quoting for the work to some big Silicon Valley companies, the ones you'll have heard of. And he says, I can teach your developers how to do better TDD. Really? Prove it. Now, how many of you have taken a training course, whether it's a week, a day, whatever it is, and you haven't been tested before and after? I assume it's most of us. We go and do a 3-day TDD course, test design, advance this, whatever it is. There's very minimal testing going on. So what he did is, on this, the left-hand side, this is what he set as a pre-class test. Essentially, it's about tax calculations in the USA. So write a bit of software using test-driven development. These people are supposed to be reasonably competent. They're working for a Silicon Valley company as software developers. And send me your code. And he then analyzed the code. And I think the first class had about 30 students. They did the class, and at the end of it, about 2 weeks later, he gave them this problem, a similar level of complexity. And he looked at all the results. And he's done this for many, many times in many companies. And this is the sort of feedback that he wrote for them. So you can see here for this particular candidate, he says, good improvement compared to pre-assessment. Looks like you applied some, that's a subtle English word. It's very polite praise, which means you're not very good, by the way. So you applied some principles, but there's still large scope for improvement. He actually had 11 code smells. Code smells are mistakes that people are making in software code that makes the code look like it isn't very good quality. So some examples is hard coding a number, like 33 or 42 or 1,337 in the middle of the code without explaining what the purpose is. Because the next person looks at it and says, what the hell is this number for? But you don't change it because you don't know what it's there for. So it's called a magic number. Dead code means it's code that will never be used. Duplicated code is very common, surprisingly common. You copy this bit to there just to see if it'll fix the problem, and then you forget to merge them and improve the code, et cetera, et cetera. He then gave a sort of a written assessment. So he says, you wrote one test using something called mock objects. Are you familiar with mock objects? A way of simplifying the testing, et cetera, et cetera, et cetera. And we have a before and an after in terms of test coverage using some open source tool. Here's some examples of person B, person C, and person D. And without a degree in software engineering, we can see there's some differences in the color. Green tends to indicate good, yellow, yeah, and black, less good. So we can see there was some improvement, and he did this and was sufficiently convincing that he got repeat work from Silicon Valley companies. He actually was able to demonstrate whether his people made improvements the ones he trained, and some didn't, and he was clear about that. And then you have to look and say, why aren't people learning? Why aren't they improving? So this is where my talk started. When I submitted it 6 months ago, I can't remember exactly, I was working with a company in India, and I realized that one of the hardest problems we have in the industry is trying to provide guidance. So if I pick Isabel, I hope you won't mind me picking on you. You've held up your hand for a certificate, so you're probably familiar with equivalence partitioning, boundary value, state transition, and a bunch of other ones. Yep, so she knows at least 3 of them. So when she's facing a testing problem, she has to think through, am I going to use any of these? I'm going to use a different technique. Do I want to use test automation? How the heck does she know? What guidance does she get to help her improve the testing that she does? So this friend of mine out in India has got a little company. He's called Pradeep, but you'll hear a bit more about him. Came up with a little sort of application, which I'll show you now, about ways to help guide testing. I'll explain what it does and what I hope it will do in future. Before I do so, have any of you heard of something called heuristics and software testing heuristics? Anyone at all? Has anyone heard of James Bach? Okay, a very small number in the audience. All right. How many have heard of ISTQB? Gosh, I hope all of you have, because that's kind of the branding of this place. Right. So there's a sort of, let's call it a difference of opinion in the software testing community. And the difference of opinion is roughly that certification is one way of improving software testing. And other people say that certification is misguided, and there are other ways that may be better at helping people improve the way they test software. James Bach was one of the 3 people who coined the term exploratory testing about 20 years ago. So when you see that in the syllabus and the glossary of terms, it originally came from him, Kem Kaner, and I think Brett Petticord back in the 90s. And now it's become a commonplace term. And one of the ways they realized that might help people improve testing is a little sort of aid memoir, something in your head that says, if I try these things, it might help. So what we've got here then, I've changed the order to its alphabetical order. All this stuff in gray are all different words from this person's website called Functional Testing Heuristics. And that says if I'm doing some functional testing, perhaps it's relevant to test timing. Perhaps it's important to the testing we're doing. Does that make sense? Would anyone disagree that timing might be relevant to our testing? All right, I'll take that as a yes. Delays might be relevant, batches, etc., etc. But there's quite a lot of words here, and to be fair, I don't think any of us are going to do a lot of testing where we're going to think through 40 or 50 different possible areas to focus on. So he's got one called San Francisco Depot, which is 6 letters, and their structure, data, platform, operations, function, and time. So this is work about 10 years ago. And the theory is that if we use these little mnemonics as a way of reminding us while we're testing, perhaps we'll do a little bit better testing than we did before. That's all it really is. Now, whether it's been scientifically measured or not, I'm not sure. But this is kind of where we're coming from in the industry. So this is this little website called Testalytics, and at the moment it's in demo mode, really, but I was playing with it at the weekend. And this was what I saw 6 months ago that gave me some hope. So essentially, it goes through a 3-step process. The first is to help me think about what do I want to test this time. This is for mobile applications, by the way. I do a lot of work with mobile. So I want to test search and usability, file handling, and the effect of changing the settings. The bug that I showed you, the 4.4 Android egg bug, was to do with the settings. So clearly, we hadn't done a great job of testing it. I thought, OK, let me make sure we're going to test that this time. I want to test it on a couple of different phones. I picked 3 here. I might as well test it on a couple of different networks. Well, it's an Android application. OK, I'll test it on Vodafone, whatever. And I really want to focus on 2 things, functionality and user experience. Those seem important to me. This app, by the way, is Wikipedia offline. It's a little application called QX. And we have about 50,000 active users on Android, and then we have users on other platforms. And we have it in about 50 different languages, including Hungarian. So the next thing then is what he calls model selection. Has a lot more than this, but these are all different mnemonics. or heuristics. And what I've done is I've ticked off a couple of them that I think seem relevant. And this is an example of one called M-Coaster. And the M merely says, what's my mission in testing? What am I trying to achieve? C goes to coverage. O, are there any obstacles with the testing? Well, in our application, it's a little application of about 20 megabytes, but you can download a 60 gigabyte copy of Wikipedia. Now, does anyone see an obstacle with downloading 60 gigabytes testing? Anyone pay for their data here? You may pay for a gigabyte a month, or 5 gigabytes a month, or 10 gigabytes a month. Very few of us have a contract that allows us to download terabytes. And if you want to test this quite often, it might be an obstacle. So we may need to solve that testing problem. Who's the audience for the app? Well, it's the offline Wikipedia project. So let's assume that most of our users are offline. They're around the world. Status, well, perhaps it's not that relevant. What techniques do I use for testing? And the environment, testing environment. So Android, different platforms. With me? That's kind of all the heuristics there for. So this is a sort of reminder, and it's a little bit complicated on the screen. So for searching, usability, file handling, and settings, those are the 4 different areas I wanted to focus on. I picked this little thing called SPIES. And SPIES is actually looking at things like special characters, pages and content, integrations, error messages, and special formats. English doesn't have accents. We have 26 letters, and we're very happy with our 26 letters. Well, Hungarian has a bunch of funny little accents. So we found that when we test it with accents, and I speak a bit of German, so umlaut is quite a common thing in German, we find that the search doesn't work very well with umlauts. Well, remember that I said we were limited by our worldview? So I knew a bit of German, so maybe I'm not so limited in my testing of German, but what about Arabic? How do I test Arabic? How do you test Arabic? So this is really important from a search perspective. And our biggest complaint in the App Store is about poor searching. We know we need to improve it, and for a bunch of boring technical reasons, we're having some challenge with doing so. So I want to make sure I test that. Here's the sort of progress report. This is what I'm working on. This is the testing I've done, and it's what I need to focus on. So it helps me keep track of what I'm doing from a testing perspective. And from a management perspective, we can also see how well I'm doing. Here we can see I found a bug. I'm a bit slow, I apologize. 2 hours and 20 minutes to find one bug. Well, perhaps you'll do a bit better than me, but it's quite nice to keep track of what we're doing. And quite often we're facing time limits. You've got an hour to test this in, etc. So we need to keep track of that. So I want to now talk about what I think the next steps are for this. The first thing is that if we look at these acronyms, these heuristics, like M-Coaster, there's one of them I was thinking, maybe that doesn't work so well for me. Isn't that relevant? So wouldn't it be nice to create our own custom heuristics that says, for me, for this type of app, communications is really important. So I'm going to make sure I test that. So if the system's able to score this and say, by the way, you found more bugs, when you're testing focusing on communications, perhaps that'll help provide some recommendations for the next time I'm testing this app or a similar app. The next thing is to provide guidance across the 1 million apps that are in the App Store. Lots of people at the moment, lots of companies, lots of academics are trying to test all the apps in the App Store, so 1 million plus apps. So what can we learn from doing that? And we want to get guidance on the common problems like Microsoft found. The next thing is, how many of you, you've all filed a bug report, haven't you? Yep. So one of the things I did in a conference called Star West, and I've done at a few other conferences, run something called a testing lab. A testing lab is where we have an area over there, and people from the audience come and test the software voluntarily in your own time, perhaps when you're drinking a beer this evening. And you test the software. We happen to be testing some software to help the Red Cross in America manage a bunch of things. Make sense? So we're doing some social good, we're testing the software, and I was trying to help people, encourage people to test them. So I looked at the bug reports we got. We had about 40 or 50 bug reports from people like you who'd come to a testing conference. And sadly, the amount of bug reports I got which said, I clicked on the button, it didn't work. Now, imagine the developer is in another country, which is quite often true on these projects. What the heck can they do with that bug report? Which button? What were you using? What else did you try? Did you try a different browser? Give me a clue. And these were supposedly at least adequate testers, ones who had gone to a conference. So it's really important to get guidance on what sort of things can go wrong. How many of you test an Android application? Anyone? 1, 2, OK. For the 4 or so of you who test Android, 1% of the audience roughly, The biggest cause of bugs on Android is API version. So if you're going from Android 4.3 to 4.4, there are changes to the APIs. That's the biggest single thing that causes bugs in applications, because the behavior changes subtly. The core Android libraries. This is academic research. If you don't know that, then you're just testing, I'll test on this phone, I'll test on this phone, without any rhyme or reason. So understand the underlying data helps us to know what to do in terms of our testing, so that when we file our bug report, we say, I found it on this version, I tested on that version, it happened here, it didn't happen on that version, I tested on this screen size, it happened here, it didn't happen there, and then I can action that bug report. I can actually do something useful with it. Again, from Microsoft Research, this is from 2010. How many of you use an IDE, like Eclipse? IntelliJ? Android Studio? Wow. So what the heck do the rest of you use? OK, never mind. For those of us working in software, we're in what's known as a data-rich environment. Michael, you write code, don't you? So Michael writes code. So you said you were doing some live coding tomorrow, is that right? So it's going to do some live coding tomorrow. So at the end of writing a bunch of code, you'll probably commit it to a source repository. So you'll commit it to a source repository, and you'd like a little comment saying, made this change, added this wonderful new feature, fixed this bug, whatever, and press save. And that then gets stored somewhere in a source code repository. We can go back and look at all the commit logs, as it's called, of Michael's changes and whoever else is working with you. And over time, we can build up a pattern. And maybe you fixed a bug report that Isabel reported, bug 73. So he fixed bug 73, and he puts in his little commit message, fix bug 73. The system automatically keeps track of all this for us. So software development is such a data-rich environment. Everything we do pretty much is on a computer. We're testing software. Every time we visit a web page, the web server writes a little log file saying, this IP address downloaded faveicon.ico, whatever it was, or downloaded homepage.html or .asp or whatever the heck it is that we're doing. So all this data is available to us. Most of us in our organizations, when we write reports, we say, for the last release, we tested a bunch of stuff. We got most of the way through our regression pack. We found 73 bugs. Of these, 3 was severe, blah, blah, blah. Yep. So this is our reporting. But are we actually looking at the sort of factor analysis? Why did we only make it 70% through the regression pack? Why did we find 3 high-priority bugs? Was there a common cause? Was there something else wrong that was prohibiting us from doing this work? So until we do that sort of analysis, we don't get any insight as to how we're going to improve things. Anyone got live applications? You've got real users right now? Not many of you? OK. So let's pretend just for now that you work for Amazon. So Amazon, you're all responsible for Amazon now. They've pushed a software update, and it's according to my watch, it's 4:55 local time. So whatever that works out in Californian time, you've pushed a release, and we've just noticed that the error rate's going up slightly. About 0.5%. Oh, really? 0.5%. So we're looking at the alerts. We now know what's happening. We know we've made a change. We know the error rate's going up. What are we going to do? Do we revert? Do we go forward? Do we get the best team who are down there about to go to the bar and send them out and say, go and look at the code, take your beer if you must, but go and fix the bloody thing? So that's where we need to think about the recommendation. Are we going to go forward, back? What the heck are we going to do? Next thing, it's, what's the date today? 25th? What's the date? 24th, 25th? 24th. So we're, what, roughly 2 months from Christmas? People are going to get excited in Christmas. If you're in America, you get even more excited at Thanksgiving, because that's the biggest shopping period. So we know we're either a month away or 2 months away from the shopping period. We can say that we can look at the usage of the website. It's growing by 15%. Well, we reckon it's going to go by 20% because Thanksgiving's coming. Yeah? So we've got 173 servers. Do we need some more servers? Yeah, maybe. We'll get another 20 servers. However, more important is to look at what can go wrong. When is the current rules, the current linear growth, going to change the behavior? And with computers, what we find is there are bands where the behavior is similar, particularly in things like performance, because let's say it's working in RAM. And then at a certain point, it exceeds the available amount of RAM or resources, and it fundamentally changes the behavior. It goes from being nanoseconds to seconds, because now it's got to swap everything out to disk. So the behavior changes, this step change, and part of what we need to do is be able to detect this before it happens. The linear forecasting isn't enough. So then we can look at a similar approach to testing based on analytics. So I test mobile applications. There's a nice website called opensignal.com, and they have a little application you can download for free. You run it on your phone, and it checks the mobile phone signal and the Wi-Fi. And if you use it, it'll tell you where the free hotspots are in the world. So if I happen to be flying to Budapest Airport, I can find out, oh yeah, there's a free Wi-Fi, and it's called this. Good. So it's got a sort of a value to the user, but it's also got a value to them. Have a guess how many thousand different Android devices they reported last year. Is it 1 to 10? Put your hand up when you get to the right number. 1 to 10 different Android devices. 10 to 100? 100 to 1,000? 1,000 to 10,000? 10,000 to 100,000? 100,000 to 1,000,000 different device models. Most of you are clueless. That's fine. Be as soon. It was 25,000 devices, give or take. So different models. Samsung was 40% of that across all the different Samsung models. And then I think it was LG, and then Lenovo, et cetera, et cetera. All the data is available for us online. So that we can actually look at this free of charge. And if we're not testing on the most popular devices, maybe we want to think about doing that. But let's make decisions based on data. Locales. I was testing a global application in London. Our team came from around the world. We were sitting in Soho, very happy. We probably spoke about 20 different languages between us. We tested in one language, English. Someone looked at the analytics, which was online. Our biggest usage was in Paris, France. Now, even English people know that they speak a different language there. So they speak French. So we realized we have to actually be testing in the language where our users are using our software. So all this is kind of simple database of information. But we also need to look at different usage patterns, things that we didn't expect in how our software is being used, because that's where the real insight comes, and this is things like the anomaly detection on the right-hand side. I can't remember if I mentioned, but I'm doing a PhD part-time. My supervisors are grumpy because I'm taking too long, but never mind, that's fairly normal. And what I'm trying to do is find a way to recommend tests. I assume you've all got a collection of tests that you know about in your organization, a test pack. Whether they're automated or done by human beings, not really important. And you can probably count them. I've got 753,000 tests. OK, which of the 753,000 tests will we run next? Does it matter? Do I just do the same regression pack I did last week, last month, last year, the year before that, a decade before that? Can we make some recommendations that says, perhaps we should do these ones a little bit earlier than those ones? Why? Well, those ones we understand from production are either less relevant, or we're confident in the behavior of the code, or we haven't changed it because Michael, despite all his hacking of coding, didn't touch the login module. Thank you, Michael. So at least that bit still works. The second thing is saying if we've got a bunch of tests, and typically these are automated tests, and we're testing something like login, perhaps we've been testing in English, and now we need to test the login in Hungarian, in French, in German, in Gujarati. And the amount of websites that broke when, you know the domain name, the HTTP, www, blah, blah, blah? It changed from being American ASCII English to Unicode a few years ago. So you can actually have URLs in Urdu or Arabic. Now, how many of you knew that? How many of your software projects even think of testing this aspect of it? Well, if you're not, maybe it's relevant. So perhaps we need to use the data to drive our existing tests. And the third type of test, the new tests, which say, we didn't realize people were using our software this way. Perhaps that's useful. We'll improve and do new tests, perhaps automatically, and then that will help improve our testing. I talked a lot about how the machines are improving the testing and how they're doing a good enough job of finding a lot of the bugs for free. So let's talk a little bit about the human beings. This is from an academic paper. There's a reference if you're interested in reading it. And what we've essentially got, this little red circle, which is a keyboard thingy. Someone's pressed a key on this touch screen, and we've got a little network message, which is the dotted line. Can you see that? So let's pretend, well, actually, the first question is there a bug? This is the behavior. We've got instrumentation. We know what the software is doing. Is it a bug? Every time the user presses a key, a network message is sent. Hands up for it's a bug. Hands up for not a bug. I'm clueless. Or the consultant's answer, it depends. Right. So let's imagine this is Google Search. And I'm assuming that most of you are familiar with Google Search. So I'm opening the mobile app, I'm in the browser, and I type "buh." What does Google do when I type "buh"? Well, it suggests possible things I'm searching for. So bed, bath, beer. Beer. Sounds good. BU. No, that clearly isn't beer anymore. Budgie. He's looking for a budgie in Budapest. What the hell's he doing? Never mind. So as I type each letter, it goes to the server, and it fetches back new search results. If so, perhaps this is wonderful behavior and exactly what we want the software to be doing. Passes the test. But perhaps this is something that is sending messages to the server when it shouldn't be. It's a bug. It's using the network. And if you're like me, and I'm paying for what's called data roaming here, and I can't remember how much I'm paying, how many euros for 100 megabytes, but perhaps it's eating all my data up so that I'm going to run out of money. So that would become important and relevant and a bug. But we don't know that without understanding context. So even with all the instrumentation and all the automation doing this stuff, ultimately, a human being has to make a decision. There was a talk, the second talk this morning, about smart, blah, 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 smart cities, smart objects, smart this, smart that. So I was sitting in that talk this morning and thinking, let me have a look at smart things online. And I found this nice little website called August. And what they do is they do door locks. And the door locks recognize who you are, and you can operate them remotely with your smartphone. Brilliant. Isn't it wonderful? I can even, Michael's going to come to visit my house next week, so I can enable Michael's phone to let him into my house, but not into my bedroom. Heaven forbid. But he's allowed to go and stay in the guest bedroom, the kitchen's open to you, Michael, even the beer cellars are open for you. Who the hell tests this stuff? Has anyone heard of the dirty cow bug? It's in the news at the moment. It's a 9-year-old bug. It's in the Linux kernel. Do you know who Linus Torvalds is? OK, most of you nod. Linus Torvalds actually created Linux, for those of you who don't know. He created it anyway. This is a hard bug. So he says, 9 years on, we tried to fix this. It seems like it came back. Meh. So one of the things I was thinking about this morning is, if we're testing smart stuff and smart cities, are all our bugs going to be hard bugs? What do you think? News. This is the Guardian newspaper, but it's mainstream press. This was Saturday, I think, 22nd. Cyber attack hacker weaponized everyday devices with malware. You're probably familiar, as we are in England, that most people now buy little surveillance cameras, webcams, that allow them to look at their house remotely. So far, so good? Well, what actually happened is most of them come from a Chinese company, a particular manufacturer. There's some questions about whether the code is rogue or not. And on Saturday, essentially millions of them were all told to attack different websites. One of them was PayPal. So they attacked PayPal and a bunch of other big sites. They caused some damage. Why did this happen? It wasn't this bug. It wasn't because there was a bug in the Linux kernel that 3 people in the world even understood what the hell they were talking about. It was this bug. This is a website, default password directory for all these internet-enabled devices. Oh, look at this. Let me think about this. Let me try and log in. Admin 123456. Admin. None. What? Are we serious? We've got hundreds of millions of devices connected to the internet with default passwords like this. So I challenge you that the harder problem for us ain't solving this bug, is making software that's usable and making sure we test the usability of it so that when your mother, brother, child buys this damn device from your local electronics store and plugs it in and tries to get it working on their Wi-Fi, they're smart enough to change the default password. If we can't solve this problem, then good luck to us in 10, 20 years' time when we realize that worse things are happening and going wrong on the internet. I think I'm coming to the end of this now. So last week I was over in Ireland, and I happened to be reading about medicine for some weird reason, because I came across this concept of high-value care. I've got 4 quotes for you from medicine. So the first thing is that they're talking about medicine. In the States, this is where they spend in the order of, I think it's $735 billion are wasted in medicine. So they're trying to look at improving medical practices so that if you're going for an operation, they don't automatically do all the tests on you. Because they realize that actually not only are the tests not always useful, sometimes they harm the outcome for the patient. But because of the way the American industry and insurance has come about, there's such pressure for a doctor, a physician, to prescribe all the tests that they do. And there's so much money wasted through this. So this is what the doctors are saying. So they're saying, let's make sure we improve health, avoid harm, and reduce or eliminate wasteful practices. From software testing, perhaps we can do something similar. Perhaps we can find ways to improve the health of the software and the team, avoid harm, and stop wasteful practices, whether that's regression testing or whatever the heck is that we're doing. The second thing is they talk about 1-minute consults, and we heard about smart objects. Well, believe it or not, doctors already have smart testing. And these are the sort of 1-minute quick checks of Isabel, Michael, me, you, that says, does this patient look like they've got problems with the heart, the breathing, this, that, and the other? They can do a basic assessment within a minute and then make a slightly better prognosis of what they're going to do in terms of the treatment. So perhaps we can find similar techniques in software testing. Next one, I'm sorry, is a little bit longer. But they're talking about tests that are ordered without evidence. So in other words, just go and do the testing. Now, how many of us are told to go and do the testing of the app or the software without knowing why we're doing it? So all they're asking for is to have some evidence, a bit of data, and as importantly, think about whether testing may be harmful or dangerous. So perhaps we can do something about that. I like this because they're talking about not actually only doing something if the benefits significantly outweigh the risk of harm and costs. I've talked about analytics and collecting data from software. It's what my research works in. So your mobile phones, whether you know it or not, are sending data back from a lot of the applications that we use. So we're using email application, Facebook, the rest of it. It's sending data back about how we're using it. This data has the potential to leak things like privacy information. It costs money because we're paying for the data connection. So we should only include this in our software if it significantly outweighs the risk of harm to the end users and covers more than the costs. As I mentioned, they're estimating they're wasting $765 billion per year on treatment where they acknowledge provides no value to patients. And I suspect that a lot of our testing in the industry also doesn't provide much value. So that's a whole lot of it. I'm going to finish with this for you. Does anyone know of Cartoon Tester, Andy Glover? So he's got a nice little blog online, so he's given me permission to use this. So this is where many of our bugs end up. We file a bug. A year later, we go back and find it's priority 4. Priority 4 is a polite way of developers saying, hang on, look at this bug, just go away. And even the large companies I worked in Silicon Valley, we had bug after bug after bug. They were like this, severity 3, severity 4, nah, no one's going to fix it. Come on. So this is a little bit more promising for us. So Isabel's now interested in looking at my bug. Yay. Wow, the developer came over and looked at our bug. That's pretty exciting, isn't it? Show me again what you're doing. This is clearly a critical bug, because not only has one developer come over, we've got 3 of them, and they're even complimenting us. And this is where I want your testing to be. I want your testing to be this powerful that when you're testing people's software, they're coming around to watch you like an artisan. So with that, that's the full image. I just re-clicked it for you. I'm going to say thank you to these people, because they provided material for this talk. This is me. You can find me online fairly easily. I'd love you to write to me, talk to me at the conference, tell me what you like, dislike, argue with me about any of the research I've done. And I'll thank you all for this talk, and I'll hand over for questions.
Thank you. So we have 3 questions till now. Do you need to read it, or you can read it much better than me?
I'll read the questions because I've got the mic, I can see them.
Okay.
So the first question is, any idea how app diff can be free to use, and how is it worth it for them? So does that question make sense to people? AppDiff is the tool I mentioned where it automatically tests 15,000 Android apps at the moment, and free of charge, it looks at differences and sends back a report. This is a common model in the industry, and it does two things. One is it gains traction, and it allows them to refine their models. And the second is that it shows investors, and typically these things are backed by investors, that there's something worth investing in here. And most of the money that's made if you sell a company is because you've got users. How many use WhatsApp? So WhatsApp was something like, I don't know, 20 or 30 developers, and they were worth about $500 million each to Facebook. So you weren't buying the developers, you were buying the user base. So AppDiff, the first thing is that they get the value from the data. The second is that if you are testing your app and you want to put your next version of your app available, they will test your app before it's launched, and that I believe you pay for. Because once you put it in the App Store, any user can download it. So the news is coming slightly too late, and for most of us, we'd like the news a little bit before it goes live to potentially 1 billion users. If you look at some of the larger apps like Gmail and Facebook, they've potentially got 1 billion active users, so we want to know it a little bit beforehand. So the second question is, how do I see the interaction influencing between automated testing and heuristics-based testing? Do they clash, or do they complement each other? The first thing is that the automation tends towards heuristics these days. The example I gave you with AppDiff, with the Google pre-launch report, they know nothing about our application at the moment. You get even richer data, by the way, if you do know about the application. But in this case, let's just assume we're just doing the basic testing. So they don't know what the right answer is. They're just doing a comparison. So is my car faster than your car? Does it look more expensive? Are not absolute values, they're relative values. And for many people, that's enough. The same holds true for the testing. Heuristics, in English, we have a saying called a rule of thumb. And we have an old imperial measurement, which is an inch, which is roughly 2.5 centimeters. And we'd use a thumb and go 1, 2, 3, 4. And we'd measure across there, and we'd say that's maybe 18 thumbs, which is roughly 18 inches. So that's what's called a rule of thumb. And a heuristic is something like this. It's fallible. It's wrong, because this may not be exactly an inch. It might be 1.1 inches. But it's good enough to get us better than where we were. So in terms of software testing, the real value I see for us using heuristics is it helps remind us about things we might otherwise forget. Like Isabel this morning saying she tested this thing for 2 hours. Of course I should have done this as boundary value analysis. And once she realized it was boundary value analysis, off she went and sorted out the problem fairly quickly. So heuristics help to remind us of these little details and say, of course I've got to test communications for a mobile app. Of course I've got to test the upgrade path. I work with an Indian company, and they have in the order of 50 million users of a mobile app. Now, quite a big app, isn't it? 50 million users. What they realized is if they released updates to the apps too often, their users refused to install the updates and actually complained about it because data is so expensive in some parts of India that if the app's 10 megabytes, and we're wildly, happily doing agile releases every week or every day, that they're having to pay for the update because it comes down automatically. So they had to find ways of slowing down the releases to keep those users happy. So they're having to use things like heuristics as a way of assessing what makes sense for them. So I see the two as complementing each other. Sometimes we also want absolute values. So we want to say that we want nothing to take longer than 250 milliseconds or not to use more than this finite amount of memory. So I think they'll complement each other to finish answering that question. The final question I have here is limiting tests. Can it create situations similar to anti-malware industry where old signatures are removed only to resurface later? I'm not sure what limiting tests mean, but I will talk to you about some of the other things I read about. I gave you one example, which was these cameras being taken control of on Saturday. But last week, there's a lot of research now talking about, you've heard of machine learning? Some of you heard of machine learning? It was talked about this morning. So machine learning is where computers essentially do a lot of the calculations and make sense, we hope, from this vast amount of data. So now it turns out that the hackers are using machine learning to work out how to hack our systems more effectively. What we say in English is source for the goose is source for the gander, which means the tools that are available for us for good, for working within an organization, are just as useful for hackers, in some ways more so, because they're less constrained by some of the ethics that we're spending our lives worrying about. Should I be doing this? Should I be looking at privacy? Screw that. Let me find a way to break into these systems, make my $1 trillion, buy a small island, and off I go in life. So I see this being one of the real areas that we need to focus on, is make sure that we're at least keeping up with the hackers in terms of using techniques.
The last question.
The last one, so that one is very simple, cartoontester.blogspot.com. Also, just search online for Cartoon Tester and you'll find it.
Okay. Thank you so much for your wonderful presentation.
The last thing I'll mention is there's a book available. I wrote it about a year ago with a co-author called Antoine. It's based on my PhD, but written for mortals. I've got a print copy here. I think I've got 2, actually, which I'm happy to give away for people with a good excuse for it. The online version is the name of the book, themobileanalyticsplaybook.com, and you're very welcome to download it for free.